Imagine if someone handed you an enormous box of chocolates, enough to share with friends and family, neighbors and coworkers, and everyone who ever knew you. You'd probably assume your generous gift giver bought one chocolate for each person in your life. But imagine instead that the box contained 70 normal-sized chocolates and 30 gigantic ones. That wouldn't make much sense. Well, that's kind of how scientists feel about the amount of matter in the universe. The vast majority of it is missing, and to find out what's going on, they're turning to space. The universe is filled with all kinds of matter. There's the stuff that makes up stars and planets, ordinary matter, which also includes you and me. Then there's dark matter, an invisible substance that outweighs ordinary matter by about 6 to 1, holding galaxies together and influencing their evolution. Together, ordinary plus dark matter adds up to 25% of the universe. The rest, a whopping 70%, is made up of a mysterious invisible force called dark energy, whose purpose seems to be pushing the universe apart. But wait a minute, that doesn't make sense either. Shouldn't all that dark energy just pull matter together? Well, scientists are working hard to solve the puzzle. But for now, we have to talk about dark energy as if it's already solved because it has been. Sort of. In 1931, the physicist Albert Einstein found himself with a bit of an identity crisis. The year before, he'd helped convince the world that E equals mc squared, the equivalence of mass and energy, was a universal law of nature. But then he'd gone on to win a Nobel Prize for his explanation of special relativity. And now the scientific establishment was looking to him to explain the results of a new study suggesting the universe was not static. It was expanding. Einstein struggled with accepting this conclusion because it challenged his long-held belief in a static universe. But eventually he realized the universe didn't have to be static. It could expand forever, and without violating any physical laws. All he needed was a little tweak to his theory. In 1917, he'd introduced what's called the cosmological constant into his equations to represent a repulsive force that kept the universe from collapsing in on itself. Now he could just reverse the sign of that constant and voila, the expansion of the universe explained. Problem solved, case closed. That was until 1998 when experiments revealed the rate of expansion of the universe wasn't just constant, it was increasing. And scientists realized Einstein's fudge factor was looking less and less correct. Today, the most widely accepted explanation for the accelerating expansion of the universe is that Einstein's wrong. His idea of a static universe never made sense, and his attempt to patch it up with a cosmological constant is even less convincing. Instead, the force accelerating the expansion of the universe is called dark energy. Unfortunately, no one knows what dark energy is or where it comes from, but scientists are confident it exists. That's because 3 separate lines of evidence converge on the same conclusion. Distant supernovae appear dimmer than expected, suggesting the universe is expanding faster than predicted. The cosmic microwave background, the afterglow of the Big Bang, shows an unexpected pattern of temperature fluctuations that can be explained by a dynamic universe. And the large-scale distribution of galaxies themselves is also a better fit with an expanding universe. So dark energy appears to be real, but that leaves another question unanswered. What is it? Scientists have put forward many explanations, none of them universally accepted. One is that dark energy is a property of space itself. Just like space-time can curve, it might also have a kind of anti-gravity that repels objects on the largest scales. Another idea is that dark energy is a kind of field. A field is like a fluid that permeates all of space, and if that field has a negative pressure, it could drive the expansion of the universe apart. Fields can also change over time, and that might explain why the expansion is speeding up. And finally, some scientists think dark energy isn't a new thing at all, but a new way of looking at gravity. According to this idea, gravity doesn't get weaker with distance like we normally expect. Instead, it gets stronger. On the largest scales, the effect of this extra gravity would be indistinguishable from dark energy. To figure out which of these ideas is right, or whether there's something else going on entirely, scientists are mapping the universe in unprecedented detail. Satellites like the European Space Agency's Euclid are charting the positions of billions of galaxies to better understand how the expansion of the universe is changing over time. Meanwhile, experiments like the Dark Energy Survey are scanning the skies for clues about the nature of dark energy itself. And next year, NASA's launching the James Webb Space Telescope, which will take infrared pictures of the early universe to see if it can spot signs of dark energy in action. With all these missions and more on the horizon, we may be on the verge of solving one of the greatest mysteries of our time. When we learn what dark energy is, it will dramatically change our understanding of reality. And whatever we discover will help answer one of the oldest questions in human history. What is the universe? And while we wait, we can marvel at the fact that such a profound mystery exists at all. Dark energy is a reminder that the universe never ceases to amaze. Thanks for watching.